I'm going to apologize in advance for talking really, really fast because I have a lot to go through. I'm Beau Gunderson, call sign November 7, Yankee Hotel Foxtrot, and I'm going to be talking to you about surfing electromagnetic waves. The most common experience of EM for those of you watching is likely the visual part of the spectrum, meaning the electromagnetic fields that our eyes interpret as visual information. And we're not going to tackle anything fancy like wave-particle duality or the difference between photons and phonons, because to have fun with radio, you don't actually need to know those things. Another common experience of EM is the Wi-Fi that I'm sure some of you are using to watch this talk. The wavelength, that is the length between the peak to peak of a wave, is about 5 inches for 2.4 gigahertz Wi-Fi and 2.4 inches for 5 gigahertz Wi-Fi. It's a coincidence that those numbers invert so well in inches, but it holds true that more hertz, or the number of waves per second, equate to a shorter wavelength, and fewer hertz equals a longer one. This graphic, which you have 20 seconds to digest, should make it totally clear. We're talking about the part of the graph to the far right, starting in the microwave spectrum. You can have lots of fun from a few gigahertz to a few kilohertz in the radio spectrum. It's worth noting that higher wavelengths have higher energy but penetrate materials less. This is why you can receive FM radio indoors, though through many intervening buildings, but your Wi-Fi barely penetrates the walls in your house. This is an example of a shortwave radio, receives long wave, medium wave, and shortwave collectively between 300 kilohertz and 30 megahertz. You can receive those transmissions from very far away, sometimes thousands of miles, because they bounce off the ionosphere. The ionosphere is also where you'll see auroras like this. Auroras are part of a group of phenomena called space weather. Sunspots, also a kind of space weather, are responsible for altering the transmission characteristics of the atmosphere as it pertains to radio transmissions. Geomagnetic storms and X-rays from solar flares also affects the atmosphere similarly. One challenging activity radio enthusiasts engage in is called moon bounce communication. You can bounce signals off the moon and back to Earth. A large part of the hobby of radio is making things harder on oneself, and people use extremely low-powered transmissions to do so. The smallest power transmission received from the moon and back is 3 milliwatts using giant dish antennas. It's about a thousandth of the power of a flashlight bulb. Directional antennas, like the one in this photo, can be used for receiving transmissions from satellites, among other things. There are many satellites within reach of hobbyists without large dish antennas, and software to show when and where satellites will pass overhead. Amateur CubeSats, that's small satellites built by groups of radio hobbyists, often contain radio transponders that can be used for communication between multiple locations on Earth. The ISS also contains an amateur transponder, and at various times astronauts who have been radio amateurs. For many people interested in radio, communicating with the ISS or via the ISS is a highly sought prize. Sunita Williams and Chris Hadfield are recent examples of astronauts who are licensed radio amateurs. Now it's probably also a good time to mention that you'll need a license to transmit on the radio, though you can listen as much as you want. With a few hours of study, you can get your license, though, and you can do the license test remotely during quarantine lockdown. Which is a new development. Radio equipment is also used to conduct scientific research. Now's probably the time to mention SDRs, or software-defined radios. These are inexpensive USB peripherals that turn your computer into a receiver for a wide range of frequencies. The Milky Way is here because you can actually look at the hydrogen line at 1420 megahertz. It's where hydrogen atoms flip between energy states and show up on the spectrum, and how the spiral nature of the Milky Way galaxy was discovered for the first time. This is a dish in the very larger way in New Mexico, where things like pulsars and quasars are researched, and you can go on a tour narrated by Jodie Foster, chosen for her role in the movie Contact, which involved radio astronomy. There's also a large community of satellite chasers who try to pin down the orbits of newly launched satellites, whether they're amateur sats, members of the Starlink constellation, or government spy satellites. Amateur Scott Tilley recently tracked down a satellite called LES-5 that was launched in 1967. It's still active thanks to its nuclear power supply, and with the help of other amateurs, Scott was eventually able to decode the data that LES-5 is still transmitting 53 years after being launched. Radio can also be used for tracking purposes. All large ships and many small ones broadcast in the VHF band using a protocol called AIS, or Automatic Identification System. The information broadcast includes speed, heading, destination, as well as the vessel's name and size. This allows ships to avoid each other, and even on hardware and small personal boats can sound alarms when a collision course is detected with another ship via AIS. Much like ships, airplanes also broadcast information about themselves via a protocol called ADS-B. There's a lot of free software that exists to plot the data received over ADS-B using an SDR and an inexpensive antenna on a map. Unlike ships and planes, submarines don't have an established protocol, but they do use radio. VLF and ELF for very low frequency and extremely low frequency, respectively, are used to receive transmissions through many miles of earth and seawater. ELF is between 3 and 30 hertz with wavelengths of 100,000 to 10,000 kilometers. And those transmissions are encrypted, obviously. Speaking of encryption, most drones use some form of it to prevent unauthorized reception or control. Despite this, researchers were able to ascertain whether where a drone was pointing its camera by using an SDR and doing something as simple as quickly making the window of a house transparent or opaque and seeing if the resulting data stream changed. They couldn't see the encrypted image, but they were able to prove the camera could see their location. Another example of this type of reverse engineering that has consequences for those of us that value our privacy is that of Bluetooth keyboards. Many use no encryption, and what you're typing can be ascertained using a cheap SDR. Other recent examples include recovering encryption keys from radio waves leaked from CPUs and replay attacks on car key fobs. Bluetooth and Wi-Fi are part of the ISM, or Industrial, Scientific, and Medical band, where things like garage door openers and baby monitors live, but also wireless power meters. And when I lived on a sailboat at Shilshole Marina, I could see the power consumption of all of my thousands of dock neighbors. You may have noticed that lots of the things I like about radio aren't necessarily about talking on the radio, though there are lots of people out there who enjoy that as well. But I live in an apartment now, and I don't have room for a large antenna. So those of you with backyards may fare better there. I'll leave you one more example of what's out there. My call sign, November 7, Yankee Hotel Foxtrot, is a reference to a Wilco album, but Wilco named the album after a snippet of a recording from a number station, a kind of shortwave radio station that transmits spoken numbers, which are believed to be for reception by intelligence officers in foreign countries. There's an avid community out there, people who log those stations and attempt to figure out more about what they are. So thank you.